All right, you guys, let's take a look at some of the things that you'll see on the expressions quiz, right? We're going to learn a little bit about how to write words as expressions, how to identify expressions that are equal to each other. And this is a review video. So here we go. This is write a mathematical expression that represents the product of 3 and the sum of y squared and 12. So right away, I see that we're talking about a product here. So I'm going to underline this, right? This means that I'll be multiplying something. It says I'm looking for the product of 3. So I'm going to be multiplying 3. So I'm just going to write here 3. And I might even write a little multiplication sign. So I'm multiplying 3 by something. So the product of 3 and the, I thought there'd be a number here, but it says this weird thing, the sum of y squared and 12. It looks like I'm multiplying 3 by a sum. So I'm going to use parentheses to contain this, right? So this factor is going to be y to the second power, or y squared, and 12. That's the sum of y squared and 12. I'm putting parentheses around it so we can see that this is a separate factor, right? So that's one of the things I'm multiplying, and that's the other thing I'm multiplying. 3 times y squared plus 12. So here we are. This is the product of 3 and the sum of y squared plus 12. Okay, so we always expect factors to be something like 3 times 4, where this is a factor and this is a factor. But we can look at a product this way also, right? 3 times a sum. All right, great. Let's take a look at something else here. All right, so here's an example problem. We've taken this right from the SBAC sample items, so hopefully, this is the sort of thing that'll be tested on at the end of the year. It says select the product of 2 factors. So this is similar to what we just looked at. When I see product, the word product makes me think I'm going to be multiplying. So right away I think this might be a choice. This is division, so let's just cross that out. That's not a product. This is addition. Now, even though you see 2x, that seems like a multiplication problem, and 8w, those coefficients mean multiplication, we need to think of these things as terms. This is a term plus another, I don't want to call this a sum, but that's what it is, plus another term. Okay, so this is an addition problem. So D is out, right? So we're left with these products, multiplication. This is a factor, and this is another factor. That's 2 factors. So A is one of our choices. 4 squared is a factor, and just like we saw before, this parentheses groups this subtraction problem, or this difference, together as one object. This is a factor, and this is a factor. This is the product of a square and a difference. That's 2 factors. I'm multiplying 2 things together. So in this case, there's 2 choices that are correct. I would circle both of them. All right, let's take a look at another one. Circle all the expressions that represent the product of a factor and a sum. This is very similar to what we're talking about here. We're looking for a product again, right? We're looking for the product, so it means multiplication, of one factor, and it looks like the other factor will be a sum. So here I am. This coefficient 4 means I have 4 of these. We could really think of it as 4 times this amount, right? Whatever that parentheses is. In this case, that's 8. So 4 times 8. That is a product of a factor and a sum. Let me circle the A right here. It might be a little neater. All right, 3 times y. Now that's definitely a product. This is a multiplication problem. And 3 is a factor and y is a factor. But neither of them are sums, right? A sum would be an addition problem. So B is out. It's a product, but not of a factor and a sum. Here we go. 4 squared is a factor. We could think of that as 16. And y plus 6, just over here, we could call this 16 times some quantity that I don't know. I don't know what y plus 6 is. But that's 4 squared, definitely a factor. Y plus 6, definitely a factor. So this is a product of 2 factors where one of them is a sum. All right, this right here is a sum. right? I'm adding two things, right? This thing I'm adding happens to be a product, and this thing I'm adding is a product. So I might call this the sum of two products, right? But it's definitely not the product of a factor and a sum, right? I'm adding two multiplication problems. So this one is out. It is not the product of a factor and a sum. Okay, so we have two correct answers. All right, let's keep going. We're almost done with this test. All right, so here's an example of something where you're asked to write an expression multiple ways. So I think that they're going to ask us to write the perimeter, right? So let's write the perimeter, right? And one way to write this is we could say 5x plus 2, that's one side, plus another side, 5x plus 2, plus another side, 5x plus 2, plus the fourth side, 5x plus 2. I think I might have written off the screen there. I apologize. Let me see if I can get this back in here. There we go. Okay, let's keep recording. Now, there's a couple other ways that we can write this. Hopefully, they're simpler ways. One way is I can group the like terms. I see a 5x here. Excuse me. I see a 5x and a 5x and a 5x and a 5x. And if I group them all together, I would end up with 20 x's. And I could take a look at the other terms, the whole number terms, 2 plus 2 plus 2 plus 2. And I could see that that would be a total of 8, right? So that way I could write it as, I'll tell you here, this is the sum of two terms. Now there's another way I could write this. I could rewrite this as a multiplication problem, right? I could say that this is 4 groups of 5x plus 2, right? This would be the product, because I'm multiplying something by 4. My coefficient is 4. Product of a factor and a sum. Okay, so there's a product of a factor and a sum. All three of these things are equal to each other. And that's a really important idea to know, right? So I'm going to rewrite this over here real quick. 4 times 5x plus 2. And I'm going to use the distributive property to prove to you that it is equal to 20x plus 8, right? So we're just going to distribute this. 4 groups of 5 would be 20. This is 5x, so we're talking about 20 x's here. And I can also say I have 4 groups of 2. That would equal 8, right? So these two amounts are equivalent to each other. And you should see the other video, the previous video, to see another proof of that, right? But right now I just want you to understand that these things are equal to each other. This expression and this expression are equivalent. This expression up here, this really long one, is also a third way of writing that. It's the same amount. All of these are the perimeter of this square. All right, this is getting long, but let's keep going. I think we got 1 or 2 more problems. Oh, actually, this is the last one, okay? So this is another kind of problem, right? They're gonna give you one expression, and you're gonna try and choose all those that are equal to it. So 12n plus 24. This can be factored, right? We can look at the 12 and the 24, and we can factor them, right? We can divide them both up. For example, I could divide them into 3 groups of 4 and 8. And we can check it by doing the distributive property. If I had 3 groups of 4n's, that would be 12n. If I had 3 groups of 8, that would be 24. So this is an equivalent expression. Oops, I didn't want to do that. All right, looks like I scribbled all over that. Let's switch colors real quick for the next one. Let's see if this is correct. I'll use the distributive property again. 12 times n 12 ends. 12 groups of 2, 24. There it is. B is the correct answer. Here is that long one I was just looking at, right? I can see all of these n's. If I group them together, 4n plus 4n plus 4n would be 12n. So switch colors here. 12n. 4, 8, 12. Boom. I'm going to check the 8s. 8 plus 8 plus 8 would be 24. So C is also equivalent. All right, maybe this last one is equivalent too. Let's use the distributive property to check. 6 times 2n would be 12n. Yep. And 6 times 12 would be 72. So not 24. This one is not one of our equivalent expressions. All right. So that's just another quick review of all the sorts of expressions that we've learned in the last week or so. All right. Do good work. Okay? Good luck. Actually, I shouldn't say good luck. You're going to do great.